Hi there, in this video we're looking at the surface area and how we find that. In this video we're going to look at prisms and polyhedra specifically. So we've got some areas of common shapes down the sides just to remind us what they are, and then we'll talk a little bit about what our general strategy is through this first example here. Okay, so this is a cuboid. Let's say it's 3 centimeters, 4 centimeters and 6 centimeters. Okay, so the surface area is the area of the surface of the shape. So if you're going to paint this shape, it'd be a measure of how much paint you'd need to cover it. And our general strategy is going to be to identify all the faces on the shape, work out the area of each face, and then add them up. So a good tip and a good strategy to do that is to number each of the faces. Okay, so a cuboid has 6 faces, we should know that. But if we number them, it just helps us keep track. So let's call this one number 1. Now generally it's quite a nice idea where you can to number these guys in pairs. So this surface, this rectangle on the top, and that has a corresponding rectangle, one that's the same, and that we can't see. And that's actually the one that's at the bottom of the shape here. So if we call that one 2, and we'll sort of see why we've numbered that in a pair in a second. So then let's say that this one is 3. And then similarly, we've got this one on this side of the cuboid, which we'll call 4. Okay, and then finally we've got the front one. So this rectangle here, we'll call that one 5. And then the one that's at the back, which we'll call 6. Okay, so now we've numbered up our faces. It looks a little bit messy, but when you get sort of more used to it, you'll be able to not necessarily label every single one of them. You'll just be able to write 1 and 2 without this second arrow. But just for completeness on this first one, we will label up all of the sides. But now is our opportunity to start working out the areas of each of these shapes. Now to do that, we need to work out, well, they're all rectangles. To work out the area of a rectangle, we need its length and its width. So we need to figure out what the length and the width of each rectangle is. So actually on this case, it's much easier to see 5 and 6. So we'll start there. So 5 is this rectangle here. And again, sometimes it's quite useful to just draw it out. So 5 has a height of 3, or a width of 3, and a length of 4. Which means that the area is equal to 3 times 4, which is equal to 12. Okay, so the area of that first rectangle there is equal to 12 centimeters squared. So that's the area of 5. Now we'll start to see why we've paired these up now. This back face also has a height of 3. It's a cuboid, so that length is the same as this length. And it also has a width of 4. So this length here is the same as this length here. So this back rectangle is a 3 by 4 rectangle. And so number 6 also has an area of 12 centimeters squared. Okay, so it just saves us a little bit of work, a little bit of thinking. Let's have a look at these green ones now. So let's have a look at number 3. So number 3 is this rectangle here. Let's draw it on in green so you can see where it is. Number 3 is that rectangle there. Now the bottom of that rectangle we can see is 6. But there's maybe a little bit of question on what the height of the rectangle is. But if we look, the height here is the same as this height here, which is 3. So this is a 6 by 3 rectangle. So the area is equal to 3 times by 6, which is equal to 18 centimeters squared. And using the same logic as before, this face on the back, or on the left-hand side, I should say, is also 18. So 4 is also 18 centimeters squared. So we're homing in our answer now. We've just got one more pair of rectangles to do. So we've got this 4 here, or sorry, this one is this rectangle on the top, So we need this length, which we can see is 4. So again, let's draw it out. We'll draw it how it looks there. So this length here is 4. This length here is the same as this length, which is 6. So then the area is 6 times by 4, which is 24. And similarly for 2, the area is also 24. Okay, so we're nearly there. Now our final step is to add up the areas of all 6 of these faces. Now at this point it's worth just checking that we've got 6 numbers that are adding together. We know that a cuboid has 6 faces, so we're expecting 6 areas, which we do. So now on to our final step. The surface area is equal to 24 plus 24, oh no, a little bit. 24 plus 18 plus 18 plus 12 plus 12. Let's add them up in pairs. 24 plus 24 is 48. 18 plus 18 is 39. 12 plus 12 is 24. And so if we add those up, 48 plus 24 is 72, plus the 39 is 111. Let's just double check that. 48, 39, 24. If you're ever unsure, there's no shame in coming to the side and doing one of your written methods, especially the non-calculator paper. 8 plus 9 is 17, plus the 4 is 21, 4 plus 3 is 7, plus 2 is 9, plus 2 is 11. Yeah. So we get 111 centimetres squared. A really common mistake with the units is to write it as centimetres cubed, because it's a 3D shape, but it's a surface area, so it is still centimetres squared. There we go. So regardless of what shape you've got, this is always going to be your strategy. Number up and label each of the faces, work out the areas of each of the faces, and then add them all up. It doesn't matter how complicated your shape is, that's always going to be your method. So we'll move on to a second example where we'll look at a different shape where it's not all rectangles. Okay, so looking at a slightly trickier example this time, example 2. So rather than a cuboid, we've got a trapezoidal prism, and you've got a triangular prism to have a go at home. So follow along with the steps I'm doing here, but with this question at home, I'll sort of prompt you when it's a good time to pause the video and catch up. Or if you feel like you're able to have a go at this now, feel free to pause the video and then you can check to see if you got it right at the end. Okay, so here we've got the one I'm going to do is our trapezoidal prism, and what we need to do is try and find, first of all we need to label up all the faces. That was our first step, so let's do that. So as I'm labelling up this face, or once I've labelled up this face, this shape, try and label up yours. So we've got this one at the front, we'll call number 1, and the one at the back we'll call number 2. Because it's a prism, I know that 1 and 2 are the same, so I'll be thinking about that when I'm working it out. So then we've got this slanted surface on the side, we'll call that 3, and we've got this slanted surface on the side over here, we'll call that 4. And then we've got the top surface and the bottom surface, we'll call those 5 and 6. 5, and on the bottom 6. Okay, so you've noticed I've labelled them up slightly closer to the shape than I did on the last one, and that's because it's a narrower page, so if we're working down the page I can then just write 1, 2, 3, 4 down the side here. But now's a good time to stop and have a go at labelling up your triangular prism. There's only going to be 5 surfaces here, this one's got an extra face, so once you've labelled up your 5 faces, carry on and we'll see how we go from there. Okay, so let's have a look at these red faces first of all. They're going to be our trickiest ones because a trapezium, it's the hardest of our shapes to find, but let's do that. So the area of one is equal to, well, the area of a trapezium is this half a plus b is the average width. So we take the width on the bottom and the width on the top, and we find their average. And what I will do just before we go any further, I'm actually just going to draw this out. And it's usually a good idea to draw out the shape with all the information we need on it. So it's 10 along the bottom and 4 along the top, and the trapezium's 4 high, which is important because we need the height as well. So it just allows us to pull over the information we need from the 3D shape up here. So the area is our average width, well the average of 10 and 4 is 7, times by a 4 is equal to 28, and that's for number 1. So the area of that first shape is 28 centimetres squared. Similarly, because 2 is exactly the same, I know that the area of 2 is also equal to 28 centimetres squared. Okay, let's now move on to number 3. So 3 is a rectangle again. And we need this length here, which we will say is 6. So we need this length here, which is 6. So I know that it's 6 long. Now the height of this rectangle, it's not 4. You've got to be really careful here. The length we're actually after is this length here, which is 5. So then the area of this is equal to 6 times by 5, right, do it below, is equal to 30 centimetres squared. Okay, now there are no guarantees that this other rectangle, that number 4 was going to be the same as that, but because this is 5 and this is 5, I know they are. This just happens to be an isosceles trapezium. Trapezia aren't always isosceles, so we do just need to double check. But in this case, that number 4 is also 30. And now 5 and 6 aren't going to be the same. So 5, just so we don't run out of space, the area is 4 times by 6. So I won't draw this one out because I don't want to run out of space. But again, in an exam, I sort of hope that you would. It's 4 wide by 6 deep. So it's 4 by 6, which is 24. And number 6, the area is 10 times 6, which is 60. Okay, so let's add all of these up now. So 28 plus 28 plus 30 plus 30 plus 24 plus 60. For this one, just to save a bit of time, we are going to use the calculator. 30 plus 30 plus 28 plus 28 plus 24 plus 60. And that's equal to exactly 200. How nice. So the surface area is equal to 200 centimetres squared. Well done. So hopefully you've managed to have a go at this one. If you've not, pause the video and then we'll check our answer in a second. But if you have managed to get to the end of this one, well done, and we'll see if you got it right. Okay, so let's just quickly run through how we do this one. So first thing we're going to do is label up our faces. So we've got this front face, we'll call that number 1. We'll call that number 1. We've got our back face, we'll call that number 2. We've got, and these ones I'll do all in purple, we've got this rectangle here, we'll call number 3. We've got the rectangle on the bottom, we'll call the number 4, and we've got this rectangle at the back that we'll call number 5. So let's do 1 and 2. So 1 and 2 are both the same, and we've got this rectangle, or this triangle, sorry, that's 3 high and 4 wide. Now, to work out the area of a triangle, we only need the base and the height. So I'm not going to draw this 5 on because I don't want to confuse myself. So the area is equal to a half times by the base times by the height. Well, the base is 4 and the height is 3. 4 times 3 is 12, and a half of that is 6 centimetres squared. And I know that number 2 is the same because it's the same triangle. Let's have a look at number 3 then. So number 3 is this front face. That's a 5 by 10 rectangle. 5 times by 10, which is 50. Now let's have a look at number 4, the bottom face. Now this rectangle on the bottom, this one's quite hard because you can't see it at all in this shape. But it's going to be a rectangle. It's going to be 4 wide by 10 long. So you get the area is 4 times 10, which is 40. And number 5, the area is going to be 3 times by 10, because that's also a rectangle. So then if we add all of those together, 30 plus 40 plus 50 is 120, plus the 6 is 100, the 2 6s is 132. There we go. So hopefully you managed to get that right at home. If you did, well done. If not, just double check to see where you've got wrong, and hopefully when you attempt one of these in the wild, then you're not going to get caught out in the same way. Good job, guys.